Okay, let me go over, we're in our final stretch here. So we're going to work through packets 4A today and Monday, and then your multiple choice test just over AP topics will be on Tuesday. So 15 multiple choice. And then Wednesday and Thursday, I'll give you the second part of packet 4, which is just DC topics, and we'll be going through a bunch of multiple choice problems there. I can give this to you early as well. You can pick it up Monday if you want to get a head start on that. And then we'll have a multiple choice test just over BC topics. This one will be 10 questions. And then these will add up to be 50 points, and the other 50 points coming from your homework grade, and then that will add up to your test grade. The week after next is all EOC bell schedule. So we're only going to have like maybe 35 minutes or so, maybe 40 minutes for some. It's all different. I think some days, some EOCs are longer than others. So we're just going to work through packet 5, which we're just going to work through released FRQs in the recent 6 or 7 years. And then the week after that, first week of AP exams start, May 5th, and we'll use our class time to work through packet 6. And then May 9th is when packet 5 and 6 are due for seniors. But just want to let you know, for seniors, you have a couple options. You can either show it to me and I can just flip through pages, make sure that you complete all the pages and give you credit. You can take home and use it to study for your AP exam. Or if you haven't completed it yet, you can just, maybe one of the days, maybe you still have AP exam second week, and you can just drop off packets 5 and 6 the following week as well. So even though this is senior's last day, you may decide to turn in later, which is fine. I just need to, but it is a required for your grade. Okay, any questions? So these packets have, there's a lot of pages, a lot of problems here. So we're just going to go for homework. I'm just going to be checking the odd number problems. Okay, you can use the even number problems for extra practice. Help session. I will have a help session on Monday, and really it's just going to be, if you have any questions that you have or you want me to go over anything, I won't have any, pre-selected problems. It's just really all of packet 4A, and you can just let me know if you want me to go over some specific concepts. I can go over with you on Monday. Tuesday is your quiz. I am going to have a help session for my AB students. You can come in for that if you want. Just know that if you come in for Tuesday morning's help session, I'm just going to go over derivative topics, since that's what they're going to be taking Tuesday. But you guys will be taking derivative and integral topics, all of AB concepts. But I mean, if you come in Tuesday, if you have some specific questions, I can answer that as well. It's just that I'll be going through the morning review with them on Tuesday morning, but you can come in and sit in on that if you'd like. And then next Thursday, I'll have a help session for VC topics. And then Friday, I'm going to have a help session for my AP students for their spring semester topic. All right, hopefully you guys all have the packets picked up. So packet 4A, as well as formulas and concepts. So if you're wondering about all the topics, page 3 and 4 of your formula sheet, these are all AB topics. Okay, so these are all the AP topics that we've covered. So let me just run through them just so that we can kind of visualize these, everything that we've covered first semester. So limits, continuity, L'Hopital's rule. We started with that all the way back in August. Then we moved on to product rule, chain rule, quotient rule. Implicit differentiation. This is where you find the derivative normally, like you normally would. It's just your y's feel out of place, so you have to attach a dy dx for all your y variables. Various theorems that we started introducing, like extreme value theorem, mean value theorem, roles. Questions were some students were asking questions about conditions for these theorems. It's like, how do we know what has continuity, which one has differentiability? So one thing I think maybe to kind of help you organize your thoughts around theorems, every theorem has continuity. Okay, so that's automatic. The only theorems that have an additional condition is mean value theorem and roles. So mean value theorem and roles has the additional differentiable condition in the open interval, but everything else is just continuity. So if that helps you kind of organize things a little bit, that the only thing that stands out with theorem wise is mean value theorem and roles, and they're essentially the same, right? Mean value theorem and roles are trying to guarantee a slope. Well, that's why we need that second condition. But every other theorem is just continuity. That's the only condition that is required. Related rates, right? Anytime we have a time involved through the problem, if there's a time component flowing through the problem, then we have to attach a d over dt for all of our variables. Being able to interpret a derivative graph, first derivative test, test for concavity, second derivative test. These are ways to find relative max and relative mins, or points of inflections, or concavity. Particle motion, position, velocity, acceleration. They're in that order of f of x, f prime, and f double prime. Trig derivatives, and also natural log properties and derivatives. Derivative of inverse at a point is where we create our four quadrants, and we're kind of working our way around gathering information until we take our derivative and we flip it. Linear approximation, using your tangent line to plug in the decimal. And then 12 through 16 are the integral topics, second half of first semester for you guys, for us. Riemann sums, trapezoid approximation, going through integration rules like use substitution, no long division. Cross that off. It's just synthetic division if there's a definite problem. Arc trig. First theorem, second theorem, average value theorem, solving differential equations, slope fields, and then area, volume, like this method, washer method, concept. Okay, so go ahead and start with number one. We're just going to work through the odd number problems, but I think the even number problems are good for you to maybe do some additional practice if you have time. But for homework, I'm just going to check the odd number problems. Go ahead and start, and then I will, after a few minutes, I'll start, highlighting some problems as you guys are stepping through. Two A and two B. Thank you. No, it's all. Yeah, the odds are just for this. Okay. Continuous but not differentiable means connected, but not a part of a smooth curve. So only point A fulfills that condition. And then on my key, I just added, what if we're trying to find a place where the limit exists, but not continuous? A place where limit exists, but not continuous would be point B. And point B, the limit does exist because if I pick 2 points on either side of my target, my arrows are headed towards the same Y value. Okay, number 3.
Yeah, number 1 through 15 is like for the APMs offense.
What about that?
There's only the 1 through 15.
This will be 15 problems.
Oh,
Yeah, and then Friday will be 10 problems.
Substitution.
yeah,
You do? Or is that the way?
yeah, you can do substitution.
So this one, value of 0 to 30 all t. You use your calculator for this one?
Now, you should be able to think about what can you do with that to get it to a point where you can use this.
Okay.
Number 3 is just one side of limits. We have the graph split on either side of 2. So limit is x approaches 2 from the left, approaches 2 from the right. We're just plugging in 2 and realizing that basically the arrows are not pointing to the same Y value. So therefore, there's going to be a jump discontinuity. Limit doesn't exist. Number 5, we know we have a different set of rules when we're approaching infinity. We don't plug in values, we rather compare degrees, right? If the denominator degree is higher, then our limit is 0, degrees are the same. We take the ratio of the coefficients. If the numerator is higher degree, then it's either plus or minus infinity. So in this case, the x to the fourth looks like it's a higher degree, but it's a little bit disguised because the square root is pushing it back down to x squared. So they're actually sharing the same degrees. We're just taking the ratio of the coefficients. Number 7, remember that you only want to do quotient rule if you see more than one term added together in the denominator. Typically, we should be looking to just rely on power rule first. Can we just expand our way through? That's the case with number 7. We should just bring that denominator up. There's no need to go through quotient rule. We should rely on just power rule to work our way through. Number 9, you're trying to find Pang's equation, so find a way to get your order pair, find a way to get your slope, and then point slope form. Just be aware that for number 9, we're asking for the equation of tangent line of G, not the tangent line for F. So we have to build our order pair and slope before we can put it into our equation. So don't grab the F order pair and slope as the finished product. We haven't gotten there yet. Again, your key is attached to the back of your package. So for number 9, we do have to go through product rule to build out our G prime. X and F are being multiplied. So one is power rule, the other with F, we got to just keep that in function notation. But we got to go through product rule, find G prime, plug in 2, get our slope, plug in 2 into the function to G of X to get our order pair, and then put it all together in function form. Number 11, product rule is also a good place. It's also a starting point for number 11. So 11, after we build out derivative using product rule, we have to figure out how do we get to g of -1 and g prime of -1. I think g of -1 is easy. That's just the order pair. G prime of -1, we got to take advantage of that line because we don't have an equation to find the slope of that curve, but we know that the line tangent to the curve means the line and the curve shares the same slope at that point. We could definitely find the slope of that line, rise over run. So if I can find the slope of that line, then that's a shared slope between that line and that curve at that point, because of the word tangent. Uh, 13 is the calculator question. A lot of times, if you have a calculator question, a lot of it is, can you graph it and use that graphing to find a solution? Usually it's graphing something and looking for the x-intercept. A lot of calculator active problems on the AP exam is kind of in that, with that idea in mind. I know we're just doing evens, odds, but I think number 14 is a good one to know. It's a very popular type of AP type problem where they give you a piecewise function and they tell you it's differentiable, and they're asking you for two missing unknown values. So the strategy for these problems is set the equations equal to each other, but then also set the derivatives equal to each other, and then use both equations to help you solve for the missing unknowns. Home is just odds, but I just want to go through number 14 because it has a very
I just want to make sure.
yes, yeah. So the only required problems that I'm going to check are the odds, but I think just because there's so much content that I want you to get through, which is good practice. So the fact that they say that the function is differentiable, we kind of need to have two categories in our heads. That differentiable means connected and slope exists. So we're going to use both those characteristics to help us create two separate equations. Let me show my work on this one here. So with the continuity aspect of this problem, I'm gonna set the equations equal to each other because we know it's gotta be connected at two. And then we can also set their derivatives equal to each other because not only are they connected, they're gonna connect in a way where the slope is gonna be a smooth transition from one graph to the next. So just remember that your C and your D are constants. So when you find the derivative, also treat them like how you would treat constants. Right. So CX plus D's derivative is just going to be C, because imagine this 3x plus 4, right? 3x plus 4 would just be 3. CX plus D would just be C. X squared minus CX would just be 2x minus C. And then replace all the x's with 2 because that's the point in question. And then you should be able to solve for C and then use that value to solve for D. Once you have C and D, then you're going to add them together to get your answer. $17 is also a calculator question where you're graphing something to get your x-intercept to show up. $19, we got involved implicit. and product rule, because there's a 2xy hiding in there. Okay, if you're good with page 4, go to page 5. Related rates. This is when you see in the problem, there's mentions of time, and then you have to involve derivative with time built into all the derivatives. Number three, we are building out our derivative using product rule. And once we have our derivative using product rule and our DAPT, DBPT, DHPT show up, we'll replace every DBPT and DHPT with -3, and we just kind of reason our way through what's the only way where A is decreasing only when B is greater than H, which is going to cause this to force this to always be negative. Six. It's a very specific problem involving similar triangles, the shadow problem. You're always starting off drawing your diagram this way. Your vertical components of your triangles are known, and then you're splitting the base into X and Y. You're setting a proportion equation, cross multiplying, find the derivative, and then you have three different variables, three different components. Dx dt is always the rate of change of the person walking. Dy dt is the rate of change of the length of shadow changing. And then dx dt plus dy dt is the rate of change of the shadow. Number 7 is curve sketching, first derivative test. So you find f prime, get it into one fraction, set the numerator and denominator equal to 0, create your slope sine lines, test your subinterval, and then look at your arrows. Wherever my slope is negative is where my down arrows are. So from 0 to q root of 2. Okay, let's work another 5 minutes or so. Let's go to page 9, or sorry, page 8. Calculated active problems are a lot of them involving graphing. A lot of times they'll give you a derivative graph, and you have to just be able to sketch be able to get the graph to show up and understand, oh, I'm looking at the derivative graph, so therefore above is positive slope, below is negative slope. I need to be able to find the x-intercept using my calculator so I can figure out where my critical points are.
Do that on the version you have there on the version here, the label is slightly differently down here, like 15 was just skipped over 14 to 16, but like 16 matches to 15 and 7.
Oh, sorry about that.
So I just think that's mislabeling and all that.
Got it. Let me see. Yeah, go ahead. Yeah, go by the, sorry. Go by your blank copy, and then just, yeah, thanks for letting me know so that I'm not going over the problems that you guys aren't doing.
So also, if you want to that's all the hours.
Yeah, that's right on yours. Yeah. My key is off, so I'll change the numbers on my key. Okay, so for homework, you guys will, let's see, I'm gonna split this up into two halves. So page 1 through 11, odds, will be due on Monday, and then your test is on Tuesday, so I'm not gonna check the homework on Tuesday. I'm gonna have I'm gonna check homework on Wednesday, page 12 through 22 odds. I'll send out a reminder this weekend so that you know what to, we didn't have that. All right, go make your phones. And then help session will be Monday morning.
I think it's.
Okay, but I want to still stay on track. We can plan it.
Got my quotes. Timeline. I like my big thing for screen mount. Okay, so in our number any color there.
It does, and you like.
Oh, yeah.
No, no, I didn't check. No, you're good.
So I'm hoping that what always happens to the rights, they take a lot longer.
It can make. That means.
So what's the difference?
Well, you gotta take it out, gang.
No, I don't know what's.
Oh, sorry. The answer choice is A. I created a self-question next week. And I said that point D is a place where the limit exists, but the point doesn't. The limit exists because.
Oh, they both. We don't.
Because the arrows are pointing to the same.
We get some packet. So, are we done with packet 2A?
Yes. Yeah.
Packet 2B.
Yeah. Packet 2A is AB topics, packet 2B is BC topics.
I don't know if I've showed you everything. I think I did.
Yeah, I think so.
Okay. This is how much BC stuff I have in my mind. I gotta.
It's a lot.
Get all that. It's a lot of BC comments.
It is.
Oh, we're getting the 5 on the exam.
For sure.
We sacrificed
It's.
10,000 trees to get 5. Let's
I'm
go.
gonna get a 0 on the FRQ section for using equal signs. What's gonna happen to me? Let's go.
What's the tree to 5 ratio for BC Calc? Let's trees are sacrificed, so this can get piles.
Every weekend, guys. See you Monday.
See you later.
Oh my God. Said you guys saying the name.
Yeah, it's like a spreadsheet, I think, so you can use that.
We can.
Oh, good.
Sure.
What time should I come? Should I either come to your classroom?
Yeah. Will you be here at 3:30?
Yeah.
Okay, come to my classroom and then we'll walk down there. If there's a change in plans where the cafeteria is not ready, I'll text remind you. Yeah.
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 What's like packet 5 again for like the?
Yeah. So I haven't passed it out yet, but
Because I know packet 6 is that I'm seeing.
yes, so yeah, so packet 5 are all the released FRQs. So it's just a bunch of FRQ tests. So we'll do that during the EOC week, but I'll get that out to you next week. Thanks.
So you want to?
No, you can sit there.
And then.
Once you get time for it, make a motion for this.
Can you do something today or? Oh, yeah. Anytime. If you take a class or you take it. That's getting close. Oh, got it. You have like. That was you. And I'm gonna add one story.
Sorry, I said.
Forgot.
You my own.
I forgot you had.
I'll get Ashley. No, I was thinking.
I'm just kidding, no. No. I'll be here for that. Bye.
I did ask. Yeah. Will be a bit.
Oh, really? I mean, it's fun. Okay.
Yeah, I know about this. My.
Oh, yeah. You can charge me.
Maybe here right now. Tell me. What? Yeah.
Actually, no, I did.
No, I think just. It's like.
Hi. So you're still on fast because they probably time it down.
I'll show you.
Okay, good. Oh, Colin, I want to give this to you.
My screen reads good for like. Yeah. It's got like.
Packet, and then, homework is packet. You can take it back to four. Okay, phase 1 through 4. I'll send a reminder.
Like 3/4. That was good. Why did no one else do it? Roll yourself out.
Right, I'm wondering exactly. Where do you want me to like?
Tomorrow,
Say like 9.
we're going at 9. Cafeteria.
Just general knowledge.
Okay.
Yeah, I can be there for as long as.
Oh, really?
Yeah.
Yeah, so, depending on the needs, I mean, you'll probably be a runner. Or you're gonna easily do anything that may have you run a game.
Yeah.
Sure, yeah, so, no worries. It's on there. Sure.
Like five.
Think so, yeah.
Oh, yeah, I've not done that.
Okay.
Yeah. What about hitting? And you can't legally go to this.
I heard two, I heard two, three, by the way. Good, yeah. Want me to look at which one? Oh, this is- It's like, oh, yeah, good.
Yes.
You just use data. There's Oh, it's fine.